In this lecture, I will teach you the concept of free fall. We know that Earth attracts everything towards itself due to a force of gravity. As a result, the body accelerates towards the Earth. Therefore, the type of motion in which only a force of gravity acts on a body is known as a free fall. Now let's consider that a body falls towards Earth. If I trace its motion path, I come to this conclusion that in time 0 second, the displacement of this body is 0. Hence its velocity is also 0. In time 1 second, its displacement becomes 4.9 meter. Hence its velocity is 9.8 meter per second. In time 2 second, its displacement becomes 19.6 meter. Hence its velocity is also 19.6 meter per second. In time 3 second, its displacement is 44.1 meter and its velocity becomes 29.4 meter per second. Now look at the velocity of a body. We see that the velocity of a body is increasing as it is falling down, because the body has covered greater displacement between 1 and 2 seconds than 0 and 1 second. Similarly, the displacement of body is greater between 2 and 3 seconds than 1 and 2 seconds. Hence, every second, the body covers greater and greater displacement. As a result, velocity of a body increases. We know that when velocity of a body increases or decreases, we say velocity changes. When velocity changes, acceleration produces. Hence, we get that when a body falls towards Earth, its velocity increases. Or we can say that the body accelerates towards Earth. Therefore, falling bodies have acceleration. Now here the question is, can you calculate the acceleration of these falling bodies? The answer is yes. We know that the rate change of velocity every second is called acceleration. It means if I find the change in velocity between 0 and 1 seconds, it will give us acceleration. Hence at time 0 second, our velocity is 0 meter per second, and at time 1 second, our velocity is 9.8 meter per second. Hence the change in velocity is 9.8 meter per second square. This is the acceleration of this body between 0 and 1 second. Similarly, if I find acceleration of this body between 1 and 2 seconds, it is again 9.8 meter per second square. And if I find it between 2 and 3 seconds, it is again 9.8 meter per second square. Thus, I say that the rate change of our velocity in every second is 9.8 meter per second. Or I say that our velocity is constantly increasing by amount of 9.8 meter per second. Hence we get constant acceleration 9.8 meter per second square. In physics, this constant acceleration of free fall is known as a acceleration due to gravity. It is denoted by small g. Whenever you see g anywhere in physics, remember that it is acceleration due to gravity, and its value is 9.8 meter per second square. In both cases, if a body falls down towards Earth or if it goes in upward direction. At last, let me ask you some tricky questions. If I throw a body in upward direction, what will be its acceleration at the peak point? I know that if I throw a body with initial velocity of 29.4 meter per second in upward direction, after 3 seconds, its velocity will be 0 meter per second. Thus, at the peak point, the velocity of a body is 0 meter per second, but still its acceleration is 9.8 meter per second square. The reason is that when I throw a body in upward direction, in this case, its velocity decreases. Now, how much velocity between the last 2 and 3 seconds decreases? I know its velocity decreases from 29.4 meter per second to 19.6 meter per second, then from 19.6 meter per second to 9.8 meter per second, then from 9.8 meter per second to 0 meter per second. Yes, in the last second, our velocity changes from 9.8 meter per second to 0 meter per second. Hence, my acceleration at peak point is 9.8 meter per second square. Lastly, what is the direction of acceleration due to gravity? The answer is when a body falls in downward direction or it goes in upward direction. In both the cases, the change in velocity is downward. Hence, the direction of acceleration due to gravity should always be in downward direction. I hope you have understood the concept of acceleration due to gravity.